Hey, it's Mr. Saltano, and this video is going to be on the emission spectrum. So before we go into the emission spectrum, a couple things we need to go through. You've probably seen this symbol before, right? So this is the symbol for Pink Floyd. What this is essentially showing, though, is that here is white light, and then that white light is being split up by a prism to produce all of the wavelengths of light that are in white light, right? So red all the way through violet, essentially, is going to be our white light colors. So now that we've seen that, let's take a look at what's called an emission spectrum. So essentially what we're looking at is the emission spectrum of hydrogen. So hydrogen is what's being emitted from hydrogen essentially is being sent through a prism, and then these are the specific colors that we get just from hydrogen. This is not nearly all of the colors. This is just the hydrogen colors that are being produced once hydrogen is excited, which we'll go through a little bit later. So the emission spectrum that we're looking at, here is this bar here, that's the emission spectrum. This is very unique to hydrogen. So let's go into what that means. So an emission spectrum is like a unique fingerprint for each element. And it's very unique because it shows only the colors and only the parts of light produced for that particular element. So for example, hydrogen is just going to produce these bands at these very specific places. Only hydrogen will produce in such a way. And if you compare hydrogen atoms, they should each produce the same pattern of emission spectrum, but it's very different from other elements. So again, it's very unique. White light has all the colors, but hydrogen's colors are only like this. Right, the root word of emission is emit, and then so these are the colors emitted by hydrogen. Now here's neon. Neon's very different from what we saw for hydrogen, right? These are only the colors emitted by neon. So this is neon's emission spectrum. Here are the emission spectra for various other elements. So here is mercury, lithium, cadmium, strontium, calcium, and sodium. Notice that not one of them is the same. They're all very unique to each other because an emission spectrum is unique to each element. These are the wavelengths that are emitted by each particular element only. It's very unique. Now, why is this important? Well, what's emitted from specific elements is how we get our pretty fireworks. So here's kind of a guide if you were to look up to which element gives off which colors exactly. So we have calcium would look like that, sodium like this, lithium, barium, copper. This is how, when they design fireworks, when they want them to produce a certain color, they have to pick a very certain element because of the colors that are emitted from that particular element. And so that's why this happens. So we're going to go through, and here's another example of emission spectra. And so the emission spectrum is unique for each element, and we know the atmosphere of the sun, for example, by the emission spectrum. So even though we can't get all the way over to the sun because it's so hot, we can actually tell what the sun is made of because of the emission spectrum produced by the sun. So that what's emitted from the sun, essentially. And the noble gases, which we'll go into later in the year, they give off different light when they're energized. So if you look at sodium, mercury, nitrogen, actually these are different things, but for the noble gases like helium and argon and krypton, they all produce their own colors. So this is part of this unit on electrons we're talking about. So why does this happen? Why does everybody have unique colors? Well, what happens is these colors will be produced if you take an atom and you either run electricity through it or you light it on fire. And essentially you're just pumping energy into it either way, right? So when you give energy to the atom, the electrons in the atom get very excited. And when they get excited, they jump up levels in the atom. They jump up energy levels. So as those get excited, we might see them go up as the energy is absorbed. So here's our wave of energy that's absorbed into the atom. Here's the atom. This electron has just jumped up a couple levels. Now, we call that the excited state of the atom when those electrons jump, because they're temporarily very excited as the energy is absorbed. So here we see it went from energy level 1 to energy level 2. Now what goes up must come down, right? So eventually that energy is going to be released in different wavelengths or different colors. So as that electron drops back down, that energy has to go somewhere. And in fact, it's released from the atom in different waves of different wavelengths. And then so as it continues to drop, we'll see it produce different wavelengths, which means it's different colors, because each color has a different wavelength, right? So this is what it looks like as it drops if it's emitted. When the electron drops and the energy is emitted, that's considered the ground state. So it's back down to its normal unexcited state. But the reason why this is important is because it depends on how much energy is being released. If you have high energy, for example, you might expect a violet, depending on how far the electron dropped and essentially where the electron dropped from. A lower energy light that you might see is red. So it really depends on that unique atom where the electrons climb to and where they drop down to release these different colors. And then those different colors show up as different parts of the emission spectrum. So let me show you a really good video just to show you what I mean.
If a sample of hydrogen gas is heated, it gives off light. When you view this light through a prism, you'll see an emission spectrum consisting of bright lines at specific frequencies. Because the spectral lines come at definite intervals, this suggests that specific energy levels exist in the atom. A cross-section of an atom shows the energy levels similar to the rungs of a ladder. When energized, the electrons move temporarily to higher energy levels. As the electrons fall back to lower energy levels, they lose energy in the form of light, which produces the characteristic spectrum of the element. Because we know that the emission spectrum for each element is different, we also know that the distances between energy levels must be different for every element.
So now that we've seen that, we can kind of see how those different colors were produced just because the electrons traveled, they dropped a certain level and produced different colors. And let's take another look at, here's mercury, lithium. So what we're saying is that if a mercury atom had its electrons excited, those electrons would then eventually come back down, and as they came back down, they would release that energy in the form of these different bands of colors. And these are the parts that we can see on the emission spectrum. And then there's lithium, cadmium. Each atom is going to do this in a different way. And remember, we said that those electrons, according to Bohr, can only jump up certain levels. This is actually the way that we came up with the Bohr model, is based on the emission spectra. So as the electron jumps, it can't jump between steps. It has to only step on certain steps of the ladder, and then it has to come back down. And as it comes back down, as we can see over here, depending on how far it drops, it can produce different colored bands on, here's the emission spectrum right over here. So that's how we know a lot of what we know about electrons. Now, the last important thing, you're guaranteed to be asked about this. There's a big difference between the emission spectrum, which was the whole point of this video, and the electromagnetic spectrum. They're both spectra, meaning that they have a wide range of different parts we're looking at. But the electromagnetic spectrum includes all of the electromagnetic waves. So all the way from gamma rays to radio waves, including all these other parts. The emission spectrum is uniquely emitted from a certain element. So it only includes those wavelengths, those frequencies, and those energies emitted by that particular element. So again, electromagnetic spectrum is everything with electric and magnetic properties. All of these guys are electromagnetic, but the emission spectrum is just what's emitted from an element specifically. Thank you for watching, and remember, chemistry is everywhere.